All right, so we are going to talk about the periodic table and what you need to know in order to do well on your periodic table essential skill. There are about 5 or 6 different things that you're going to need to know. So we're going to work our way through each of those. The first of which is going to be this stair-step line that I've outlined in bright red on the right-hand side of the periodic table. This stair-step line divides the periodic table into 3 basic categories. So you have your metals, you have your nonmetals, and then you have your metalloids. To figure out where the metals are, what I do is find some common metals on the periodic table and figure out what side they're on. So if you look at lead, gold, silver, nickel, iron, titanium, they're all on the left-hand side, meaning the elements on the left-hand side of the periodic table are overwhelmingly metal. This does have one exception, and that is hydrogen in the top left. We'll talk about that exception in a second. Looking at all of our metals, we do have some common metallic properties that you're going to want to know. The first is that they are very shiny. You guys probably already know that. They also are very good conductors of both heat and electricity. Some of them are better than others, but overall they do conduct both heat and electricity. They're also malleable and ductile, meaning that they can be formed and bent and reshaped without actually breaking apart. The other thing that you want to know with your metals is the reactivity trend. We did a lab with metal reactivity, and you guys saw as you moved further and further away from that stair-step line, things got more and more reactive. So that means that francium down here in the bottom left is actually the most reactive metal on the periodic table. Moving to the non-metals, those are going to be on the opposite side. Oxygen is a very common non-metal. These are all of your non-metals, again, with that exception of hydrogen in the upper left. Don't forget about that one. All of the nonmetals have the opposite properties of metals, so they are dull, they are actually poor conductors, meaning they're really good insulators. They are also very brittle. They also have a very predictable pattern in reactivity, with one exception. If we ignore this rightmost column, and we'll talk about that one in a second, but if we ignore that column, then as you get further and further away from the stair-step line, just like the metals, you get more and more reactive. So that being said, fluorine is actually the most reactive non-metal on the periodic table. The last thing to mention, or the last category to talk about, is the metalloids. This category is actually consisting of the elements that are surrounding that stair-step line. So anything that I'm highlighting in yellow right now is considered a metalloid. Notice how aluminum is not highlighted. That one is actually a metal. The thing to know about metalloids is they actually have properties of both metals and nonmetals, so they're good for very specific purposes, like electronics that have to be turned on and turned off. So the conductivity property is key with those ones. Moving on to different groups of elements within each of those categories. Group number 1, you guys can see that I have all of the groups numbered on the tops of each of the columns over here. Group number 1 is actually the alkali metals. Group number 2 is going to be consistent of the alkali earth metals. The big section in the middle of the periodic table, these are called the transition metals. And then down here on the very bottom of the periodic table, the little section that's kind of broken apart, that is made up of the rare earth metals, or the lanthanides and the actinides. These are the more, these are the elements, or more of them, are synthesized or man-made, whereas the transition metals, these are more common elements. They're also a lot harder than any of the other metals on the periodic table. They're more conductive. Copper, you guys know we use in the wires of our house, so that one has to be very conductive. If you look at the metals off on the left-hand side, the two groups that I've highlighted in blue and green over here, these are more soft metals. So the blue category over here, the alkali metals, these are actually soft enough that you can cut with a butter knife. The alkali earth metals, the green category, this one is, they're still soft, but you can bend them with your own hands, but they're not exactly able to be cut with a butter knife. They are, both of these different groups, the alkali metals and the alkali earth metals, are extremely reactive metals, so they're not going to be found in nature as a solid metal. They'll be found in nature connected to other elements in compounds. The two major categories that I want you to know when it comes to the nonmetals, group 17 is called the halogens. That's the most reactive group on the of the nonmetals. So again, you guys know that fluorine is the most reactive nonmetal. The noble gases is group 18. I'm hoping you remember that from physical science. But this is the group that doesn't want to react with anything. They already have stable valence electron shells. They don't need any more or less electrons in order to react. With that being said, we can talk about electrons. The yellow highlighting on the top with all of the different group numbers, they have a pattern as far as valence electrons. So remember, valence electrons are the electrons on the outermost energy level. So those are the ones that are actually used in bonding, and we'll talk about those when we get there. But for the pattern, you need to know that group 1 has 1 valence electron, group 2 has 2 valence electrons. You have to skip over the transition metals. These do not follow any sort of pattern with the valence electrons. Same thing with the rare earth metals. If we continue, group 1, 2, 13 through 18 are all part of the main groups on the periodic table. So these all have that pattern. Group 13 has 3 valence electrons, 14 has 4, all the way over to group 18, which has 8 valence electrons, which is the most on the periodic table. If you look at your trend in, or the similarities with your periods are numbered on the side over here, 1 through 7. These, the elements in the same period all have one major thing in common, and that is the number of valence energy levels in the atom. So every element in period 2 has 2 energy levels, or energy rings where the electrons can go. Everything in period 5 has 5 energy levels, and so on and so forth. Last two things I want to talk about are two specific patterns or trends in the periodic table. Atomic radius is a little bit easier to understand. It's the size of the atom. As you move down the group, the radius or the size of the atom actually gets bigger. And the reason for that is the fact that it has more energy levels. So down here in period 7, those have 7 energy levels, meaning that it has 7 rings for the electron to go on, so it has to be bigger than those that are up here in the second period. If we're looking at the pattern in atomic size going across the periodic table in a specific period, it actually decreases. Now, that's not something that we would typically think about, but if we think about xenon over here on the right-hand side versus rubidium over on the left-hand side, both of those have 5 energy levels. However, rubidium only has 37 protons. You guys can see that with the 37 above the RB, whereas xenon over here has 54 protons. With the larger number of protons on the right-hand side, xenon actually has a larger positive charge in the center of the atom, which pulls those electrons in tighter than the 37 of rubidium off on the left-hand side. With that, if we know that the largest atom on the periodic table has to be francium, smallest atom on the periodic table is actually helium, those are also helpful with the last periodic trend or pattern that we're going to talk about, which is ionization energy. Ionization energy is the amount of energy required to remove an electron from an atom. If you have a very, very large atom, that means that your electron that's going to be removed is the furthest away from the nucleus, meaning francium over here in the bottom left, the largest atom on the periodic table, it's the easiest to take away an electron, meaning its ionization energy is actually the smallest. The opposite is true for helium over here on the upper right. It's the smallest atom on the periodic table, which means it has to have the highest ionization energy. It's going to be the hardest to take away an electron because of its size, but also this whole column, this noble gas column, we already said is stable. It doesn't want to react with anything. It's not going to want to change its configuration, so it doesn't want to remove any of its electrons. So again, helium has the highest ionization energy, is the smallest atom on the periodic table. Francium has the lowest ionization energy and is the largest atom on the periodic table. I hope this helps review a few things for you for your essential skill in chemistry. Let us know if you have any questions. Good luck, guys.